This is RD Sharma Solution Class 12, Chapter 19. Exercise is 19.1. Indefinite integrals we are taking. Evaluate. This is the integration of under root 1 plus cos 2x by 2 dx. Now before we go ahead, there are certain standard results which we need to discuss. And these result is cos 2x or cos of twice theta is equal to there is a relationship of cos with cos square and cos with cos 2 theta with sin square also. So cos 2 theta is equal to 2 cos square theta minus 1. That means 2 cos square theta is equal to 1 plus cos 2 theta. So in place of 1 plus cos 2 theta, we can replace 2 cos square theta. This 1 plus cos 2 theta, 2 cos square theta. Okay. Now put it here. So you have 2 cos square theta or cos square x divided by 2. And remember this is under root. Inside a root, integration sign with a dx. Dx is always there, okay? Now 2 gets cancelled, cos square x will be, see if it is x square, that only means that you are having a power of half. 2 and half cancels. That is under root x square is as good as x. So in place of x square under root, we can write x. Similarly, in place of under root cos square x, we can write cos x. Now integration of cos x has to be performed, and this is sin x. Sin x differentiation is cos x. Cos x integration is sin x. But one more thing is you have to add a constant of integration. This has to be added. Okay, this is the whole thing so what we discussed is here, and this is how you have to do it. Now the same thing we have just did a question with 1 plus cos 2 theta or 1 plus cos 2x. Here also it's 1 minus cos 2x. So I told you cos 2x relationship with cos square. Now we'll have a relationship with sin square, because cos 2x is simply cos square x minus sin square x, and cos square x plus sin square x is 1. So you can use these two in order to get this 1 minus 2 sin square x. 1 minus cos 2x we want. 1 minus cos 2x is equal to twice of sin square x. When you have this 2 of sin square x, now this 2 sin square x, it is in front of you. 1 minus cos 2x can be replaced by 2 sin square x. 2 sin square x divided by 2. And this is in under root. You can cancel these 2. It has been integrated now. Sin square x is sin x only. When it comes out of the root, you can eliminate the root and you are going to integrate only the sin x in respect of dx. Now sin x differentiation what? It is the cos x differentiation is minus sin x. Therefore, the integration of sin x will be minus cos x and plus a constant. So integration and differentiation, they are complementary to each other. Now you can solve this you can write English like sentences like we have and all these since evaluate. We are integrating this one. Before we go ahead solving this question, there are certain standard results which are related to exponential and log. So if we have a log b, that simply means this is the power of b, that is log b raised a. So the power of b, which is a in this case, comes in front. Same thing is here. This is going to be used here. There is one more thing which we are going to employ, which is e raised log e. E to the power log e. This gets cancelled. That is just 1. So this we have e raised log base e. Now we need to integrate here. This 6 goes up. X to the power 6, x to the power 5, x to the power 4, x to the power 3. All 4 terms are exactly similar. So whatever I am doing with one term applies to all the terms. We have e log base e is there. Log base e is specifically given. So x raised 6, e raised log base e x to the power 5, and base e is already there. In denominator we have e raised log base is already e x raised 4 minus e log base is e x to the power 3. Now I already told you that e raised log e will be 1. So only x raised 6 remains. Here x raised 5 remains. Here only x to the power 5 will remain. X to the 4. And this is x raised 3. So x cube. And we are integrating it with respect to dx. Now we can take x raised 5 common. We'll get x minus 1 inside. Here we can take x cube common. We'll get x minus 1 inside. This x minus 1 gets cancelled. X raised 5 by x cube is x square. Because x cube will go up, it will be x raised minus 3. 5 minus 3 is 2. When you have x raised a, x raised b, that is, if the base is same, the exponents get added. X to the power a plus b. So 5 minus a. Remember, minus or negative always overpowers the positive sign. So 5 plus minus 3 is simply 5 minus 3, which gives you x square. Okay, now whole of it is x square. So integration of x square is done here. And this x square dx is simply, because all is with respect to dx, integration of x raised n is simply x raised n plus 1 divided by n plus 1. What is n here? See, n is 2. Integration is already done, so now we can forget about the integration sign. It's x cubed by 3 plus c. This is your final result. So this is how it needs to be done, and all the English like sentences we have done this, all this can be written. Now we are integrating 1 by a raised x and b raised x dx. A to the power x and b to the power x. Now integration of a raised x is simply a raised x divided by log a. The base is e. A raised x integration is a raised x divided by log base ea plus constant of c. One more thing is going to come in solving this question, which I am going to actually present it to you right now, which is 1 by, if you have ax, if you take it in the numerator, it will be a raised minus x. A raised x goes up, it is a raised minus x. Similarly, b raised minus x dx. Now we can add, this bases are not same. Okay, bases are not same. That means if you have m to the power 2 and n to the power t, this simply means mn to the power 2. Now this, if the exponent are same, you can just combine these bases and multiply them and keep one exponent over it. This is ab to the power minus x. Now this is as good as this one only. But right now I will not tell you, because it is going to come in the another exercise. There is a whole exercise for that. Just simply say that minus x is some t. So it will be as good as integration of a raised t dt. So this is simply ab to the power minus x divided by log base is e, and what is a here? ab. But here a negative sign will come, because you can just assume that we are differentiating negative x and putting it here, or there is another way to understand this, because as I said, it's going to come later on. A whole exercise will be discussing upon it a lot. But when you have this one, I'll just give you a hint what exactly we have done. We take minus x equals to t. Then we differentiate both the sides. When you differentiate both the sides, this is d by dx of negative x is equal to dt by dx. That is, d by dx of negative x is negative 1. It is dt by dx. So dt equals to negative dx, or you can say dx is equal to negative dt. We will use it interchangeably. So it is essentially equal to, the second step is integration of ab raised t. When we integrate it with respect to dt, remember dt is negative dx, so negative sign has already come. This is ab to the power t divided by log base e, and this is ab. Now t needs to be replaced by negative x, because we cannot have t we have chosen, so we have to actually replace it by x while we complete this question. Now dt is negative dx, which you see here. So we put negative dx, that is how the negative sign has come. That is why I am saying this negative sign will also come, and of course plus c constant will remain there. So this whole exercise is coming later on, but right now this is the solution. This is how negative has come, because you might be surprised how this negative has come. We've used the formula. So this is your final result. So whatever I told you, it's just an explanation, but the solution is just 2 or 3 steps. And if you add all which I said, that will be supplementary. Now evaluate cos 2x plus 2 sine square x divided by sine square x dx. So cos 2x is simply 1 minus 2 sine square x. So we'll use this one. Cos 2x is 1 minus 2 sine square x. Just replace cos 2x by 1 minus 2 sine square x. 1 minus 2 sine square x plus 2 sine square x divided by sine square x. This 2 sine square x is, and negative 2 sine square x gets cancelled. They are similar with a plus and minus sign, so you can cancel them. 1 is there, sine square x is there in the denominator. 1 by sine x is what? Cosec x. 1 by sine square x will be what? Cosec square x. We have cosec square x differentiation going on in here. Cosec square x differentiation is, if you remember the differentiation of cot x. What was cot x? It was somewhat related to cosec square x only. So integration is just the inversion of differentiation. You can write it as negative cot x. Cot x is minus cosec square x. So this comes like minus cot x plus c. This is the entire solution. Whenever you want to solve it, you have to do it like this. Okay. Similar way, we have done the formulas, applied it to previous questions. The cos 2x is simply 2 cos square x minus 1. What do we get here? In place of cos 2x, when we replace it by 2 cos square x minus 1, will be 2 cos square x minus 2 cos square x minus 1 divided by cos square x. This 2 cos square x minus 2 cos square x plus 1 you will get. That is, this when you open this bracket, you will get this 2 cos square x get cancelled. 1 by cos square x is the final thing. You always have this dx with them. I just don't write it because it's by default. 1 by cos square x, 1 by cos x is what? It's sec x. So you can just write this 1 by cos square x as sec square x. It will be squared. You have a dx here. Integration of sec square x will be tan x. And this is tan x plus c, constant of integration. This is your final result. So this is how you are going to write it. Next one is integration of e raised log under root x divided by x. Now as I told you earlier that e raised log base e will become 1 and under root x is already there. Under root x is simply x to the power half. So e raised or e to the power log base e, or if you have e to the power of log with a base e, it gets cancelled. So this explanation tracks you back to the logarithmic and exponential classes. So under root x will remain, x is already in the denominator, under root x is simply x to the power half, x is in the denominator, this goes up, x goes up, so it will be x raised minus 1, half minus 1 is negative half, so x raised negative half divided by, there is nothing in the division because x has already gone up. So x raised n integration is x raised n plus 1 divided by n plus 1 plus constant of integration. N is negative half here. Integration of x to the power minus half plus 1 divided by minus half plus 1 dx. So integration is already done, so you can just remove this sign, this snake-like sign. X raised 1 minus half is half only. The denominator is 1 minus half, so it will be half and that 2 will go up. So twice of x raised half is twice of under root x. X raised half is simply under root x. Initially also I told you this is 2 under root x plus c, which is the final result. So this is how you are going to complete this question. Okay, this is a very short exercise, first exercise, but we have over 30 exercises. Okay, so see you then. Thank you so much.